Now, triangle, similarity of triangles. So basically two triangles are similar. It's basically like this. I have this triangle, I cut this, I copy it and then paste it and make it smaller or bigger, then these two triangles are similar. So it's basically saying ABC is similar to PQR. So what is the rule or the definition of it? Two triangles are similar if corresponding angles are same. When I say corresponding angles, see this is A and this is P. These two are the corresponding angles. They should be equal. And so automatically C should be equal to R and B should be equal to Q. Right? Then I can say these two triangles are similar. And automatically we also observe in similar triangles that the corresponding sides are in proportion. What do I mean by that? AB is one side. What is the corresponding side for it? That is PQ. Equals to BC by the corresponding side is RQ. Equals to AC by corresponding side PR. So this is a true equation as well for a similar triangles. I don't know, it could be 1 by 2. That means if AB is 3 and this is 6 and if this is 8, this has to be 4 and if this is 2, this has to be 4. So that 3 by 6 is 1 by 2, 4 by 8 is also 1 by 2 and 2 by 4 is also 1 by 2. Then these two triangles are similar. Right? Maybe they could be 2 by 1, they could be 1 by 4, sorry. It could be anything, okay? The ratio could be anything, but they have to be same. That's what these are basically. The corresponding sides are in proportion. Angles have to be equal, right? So that's what this means. So there are a couple of ways to find out similar triangles. If I know two angles are corresponding angles are equal, that is if I know this and this is equal and this are equal, automatically the third angles will be equal. Why? Because the sum have to be 180. If this is 30 and this is 30, if this is 50 and this is 50, automatically 50 plus 30 is 80, this has to be 100 and 30 plus 50 is 80, this has to be 100. These two also equal. So all the three angles are equal. Then I can say the triangles are similar. Right? That's something that I can say. Or if I know one angle and two sides are in equal ratio. Right? So even if I know, okay, forget about this. Even if I know that all the sides are in corresponding sides are in proportion, that is, I don't know the angles. Right? Let's say I don't know the angles, but all I know is 3, 4, 2 and 6, 8, 4. And when I take the ratio, they're coming to be 1 by 2, then I can say the triangles are similar. And automatically these angles would also be same. Corresponding angles will be same. So that's something that I can do to talk about similarity of the triangles as well. Now, what are the applications of this, right? Once I know two triangles are similar, what can I do with that? As I said, the ratio of corresponding sides are equal. So we take the ratio as AB by PQ equals to BC by QR is equals to AC by PR. One thing I'll say, sometimes you might get to see triangles, figures being shown where you can talk about the similar triangles. That's one type. Other type is basically they'll say triangle ABC is similar to triangle PQR. When I say this, what does that mean? I have to be very careful on this. This means angle A is equals to angle P, angle B is equals to angle Q, and angle C is equals to angle R, and AB, the first 2 points, equals to by PQ, the first 2 points in this triangle. A and C, AC is the side, so it has to be PR, equals to BC, the third last two, and QR. This is what I have to write the relationship. I cannot randomly pick AB by QR equals to AC by PR equals to BC by PQ or something. Okay, don't do some random sides like this. Any two sides ratio will not be equal. I have to pick the corresponding sides, and the corresponding sides will be picked from given relation like this. The first two vertices, same PQ, that's how corresponding sides are picked and the corresponding angles are picked. So if two triangles are similar, then the sides are in the ratio and corresponding angles are equal. B is equals to angle Q, angle C is equals to angle R, and the ratio of the sides equals to the ratio of altitudes equals to the ratio of medians is equals to the ratio of perimeters. This could be asked as a question as well. The perimeters would also follow the same ratio. If I am saying these sides are 1 by 2, then automatically the ratio of altitudes are also 1 by 2, medians is also 1 by 2, and the perimeters of the two triangles is also 1 by 2. And when it comes to the areas, it is basically square of the ratio. So if it is half, then it will be half square. That's 1 by 4 is the ratio of the area. Why? Because area is basically half into base into height. So base is one side. Let's say B1 H1, B2 H2. This is one triangle and this is another triangle. This will get cancelled out. I know b1 by b2 is half, for example, if all the sides are in ratio. As I said, even the altitudes, medians are also same ratio. h1 by h2 is also half, so I will get to be 1 by 4. That's why it's the ratio square. Whereas it comes to the perimeters, it's basically adding the sides, right? A plus b plus c by a2 plus b2 plus c2. I know all of them is 1 by 2, 1 by 2. I can actually draw half common and cancel them out, right? How it's like this, right? a1 by a2 is half. So what is a2? 2a1, right? So I can do this a1 plus b1 plus c1. So a2 is 2a1 plus 2b1 plus 2c1. So I take 2 common, I get a plus b plus c, a plus b plus c. This will turn out to be half, right? So it's not really that important to know, but just understand perimeters also follow the same ratio. Only the areas is where you have to get the squares. So let's solve the problems. ABC is a right angle triangle where angle C is 90. CB is 8 centimeters and AC is 6 centimeters. Find the value of AB, DB, CD. Find the area of the triangle CDB. All of that. They said this is a right angle triangle basically. CB is given as 8 and AC is given as 6. Find the value of AB. So I know AB in this triangle, it's hypotenuse, right? So AB square should be equal to 6 square plus 8 square. So 36 plus 64 is 100. So AB is 10. So I know AB is 10 centimeters. They are asking us to find DB, that is this part, and also CD, that is this part. And they said this is also 90 degrees, right? And they are also asking us to find the area of the triangle ABC. Let me find the triangle ABC area first. It's easy, right? I know this triangle ABC half into, if I take BC as my base 8, height will be this because it's 90 degrees into 6. 2 4s are, that's 24 centimeters square. Finding for triangle CDB is slightly difficult. So here the thing is this. Easier format would be where they would say these two triangles are similar, but slightly harder, complicated problems would be where they don't give you that there are a couple of triangles which are similar or congruent, but we need to figure them out. As I said, I see 90 degrees here and also 90 degrees here. I immediately see maybe triangle ACB, triangle CDB are similar triangles. It does not look so because the triangle is tilted in a different angle. Let me draw it like this. A, C, B, this is 90 degrees, right? C, D and B, D is 90, right? So that's why I'll put D here. See what is this? In triangle ACB, angle B is this. In triangle CDB and angle B is same. Basically they have to be equal because it's the same angle, right? It's basically this line, which is what is we are seeing the entire ACB and also CDB. So angle B is also same. When I know two angles are same, this is 90, this is 90, angle B is same, automatically the third angle would also be equal. So this and this would be equal. This C is not 90 because I am talking about only this part, not the entire angle, right? This is equal to this angle. And angle C is 90 degrees, so this is also 90 degrees and this is B and B is same. It's very important for us to draw it such that they look very exactly similar, right? Otherwise, you will not be able to visualize and pick the relevant sides. Now, let me write the values. I know AC is 6, CB is 8 and this is 10. What about CD? I don't know. What about DB? I don't know. What about CB? I know it 8. So I know, right? Now I know these triangles similar because angle 90, 90, this is same, this is same. Automatically when I know two angles are same, AA similarity, this two also will be same and the entire two triangles are similar. Now I can use the ratio of the sides, right? AB by CB is equals to CB by DB is equals to AC by CD. And what is AB? 10. What is CB? 8. CB is 8, DB is what I don't know, and AC is 6 and CD is what I don't know. Something that I don't know. So this turned out to be 5 by 4. Right? I can do DB is equals to, so I can, I'm only using this part, right? 5 by 4 is equals to 8 by DB, so cross multiply. So DB into 5 is equals to 8 into 4, so DB is equals to 32 by 5. Similarly, I do 5 by 4 is equals to 6 by CD, I cross multiply, CD is equals to 6 into 4, 24 by 5. Now I got the values for CD and DB, right? DB is 32 by 5, that is basically 6.4, and CD is 24 by 5, that is 4.8. Now triangle CDB, I can again use the same logic. triangle CDB, this is my base and this is my height. So this will turn out to be triangle CDB area will be half into DB into CD. What is DB? 32 by 5 and CD is 24 by 5, right? So 12 2s are 24, 12 3 are 36, 384 by 25. Whatever the value be, that's not the important part. The important part is, figuring out that these two are similar triangles. Once you get it, you can use the ratio of the sides to get the sides, and then you can do it. This is definitely like 5-6 problems put together to show you all the applications of the things we have discussed. So don't worry, just try to think about them individually, independently, and solve them. You'll get them clear. Again, this is another question where there are two similar triangles, but the similar triangle is hidden in, basically the two triangles are hidden. See, it says AC is parallel to PQ and this angle B. So I can immediately say ACB is similar to triangle PQB. Why? Angle B is common and these two are parallel lines, so angle A will be equal to this and angle C is equals to angle P. Right? Why? Because there are two parallel lines and there is a third line cutting, so automatically this and this will be equal. And there's something like this, automatically this and this will be equal. That is what we are seeing, right? So whenever you see two parallel lines, then automatically you should look for similar triangles like this. Now I know this angle and this angle are equal and this are also equal. Automatically B are equal. So these two are similar triangles. Now they're asking us to find PQ, which is what this, right? So what is AC? 20. I know AB is 30 plus 10, 40 and QB is just 30. Now that's good enough for me. I don't need to know this. Not an issue. Any two sides ratio will be same. AB by QB should be equal to AC by QP, right? This by this equals to this by this. AB is 40, QB is 30, AC is 20 and PQ is something I don't know. So I just cross multiply. PQ is equals to 20 into 30 by 40. 21 there, 22 there, 215 there, so it has to be 15. Right, the answer is 15 for this. Right, the goal is for us to find out similar triangles and then use the side lengths as ratios to figure out the required value. In the given figure, D and E are the midpoints of AB and BC. AB and BC respectively. DE is parallel to BC. Find the ratio of the area of the triangle AD to the triangle ABC. So D and E are the midpoints. So there is a property for the midpoint. There is something called midpoint theorem. So the line joining the midpoints of two sides of a triangle is parallel to the third side. So, but we have still given it in the statement for you to solve, but you might not get this in the questions. Okay, you will not get it most likely. Understand? There's this property midpoint theorem which says the line joining the midpoints of two sides of a triangle, that is DE, is always parallel to the third side BC. That's it. Once I know it, whatever we have done in the earlier question is what you need to do here. Two parallel lines, angle A is common. This is like two parallel lines. This is the angle, third line cutting through. So this and this will be same angle. So whatever the angle I see here will be seen here as well. And automatically same angle here, I should see same here. So if whatever this is, this will also be same, right? Now I have two similar triangles, ACB and ADE. Angle A is same, angle C and angle D is same, angle B and angle E are same. Once I know it, similar triangles, just pick the ratio of the sides and get the answer. So as I said, the ratio of areas of triangle ADE is, ratio of areas is square of the ratio of sides. If you remember, right, we've discussed that. So ratio of area is what we need to find. What is the ratio of sides? I know. Let's look at this example, right? AC and AD are half, right? Because these midpoints, if this is x, this is x, this is 2x, the ratio of them will be 1 by 2. So I just need to do 1 by 2 square. That's going to be 1 by 4, right? As I'll just repeat it. AC is 2x and AD is x, right? Because these are midpoints. If I take AE as y and this will also be y because E is midpoint and this is 2y, AB is 2y. So this will be 2y, this will be y. So any two sides I take 2x by x is 2. If I am trying to do triangle ABC by AD, but they are asking us the ratio of ADE to ABC, right? Triangle ADE to triangle ABC. So I need to do any side like AD by AC whole square, because triangle AD, the relevant sides are AD by AC. Square, because I said ratio of areas is ratio of sides square. So this will be x by 2x square. They get cancelled out. This 1 by 2 square is 1 by 4. That's why the answer is 1 by 4.